Okay, today we're going to talk about function notation. Function notation is a very simple concept. It's something that we can easily do. So we're going to jump right into it. By the way, great job today on your activities outside. Outside looks great. Hopefully some people learn from that. All right, let's get fired up because it's exciting. All right, here we go. Function notation. Basically, function notation is a more user-friendly way to write an equation. Okay, so I'm not going to give you the exact definition because I want you to look in your textbook for the exact definition. But the way I look at it, again, is a user-friendly way user-friendly way to write an equation. Okay, very soon we're going to be getting into writing equations in the form of y equals mx plus b. That's the slope-intercept form. So looking ahead, we're going to be writing a lot of equations. Today I showed you the inverse form of an equation. When you're switching that x and y, that's coming. Those equations are coming. But right now, before we get into that, we'll talk about function notation. But let me show you. When we write an equation in slope-intercept form, you have y equals mx plus b. Okay? Just a little note to yourself. Slope-intercept form. Again, that's a preview of the future. Now, one thing I want to say, I want to take a second to say this. Hey, pause your video right now. Actually, pause it after I tell you this because there are some notes underneath 1.3. It is the Cornell note style notes that you can print off of your Blackboard, and you can follow along filling in your Cornell notes because I want to kind of expose you to that Cornell note, right? That note-taking strategy, okay? So if you need to, pause your video right now, go grab those notes, print them off, and then that way you have a copy, okay? And you can just write your notes right on top of that and then put them in your binder. All right. So this is our slope-intercept form, which we're going to talk in detail about later on moving forward. But if I want to write this, instead of y equals mx plus b, if I want to write it in function notation, I would write this as f of x equals mx plus b. What this says is that I've basically converted the y. If you notice here, nothing changed on this side. And right here, the y simply turned into f of x. Okay? Basically, if we remember what we've talked about so far this week, one of the things we talked about is x is independent, y is dependent. So what this is saying is that the function of x, what depends on x, okay, that's what a function is. What depends on x is equal to mx plus b. So y, it's just another way to write y. That's all it is another way to write y. Okay? So don't think anything much more than that. So again, another example might be y equals 3x plus 4. And instead of writing this in the standard slope-intercept form, we could change this to function notation, and function notation would have us write it as f of x equals 3x plus 4. These both mean exactly the same thing. All right. Hopefully that's pretty self-explanatory. So that's really all function notation is. But remember, I said it's a user-friendly way to write an equation. User-friendly indicates that I can use it in an easier manner. And so let's get into that detail right now. Okay? I'm going to go ahead and take this off, so if you need it, go ahead and pause the video. Okay? So let's say we're looking at the graph over here, and the graph asks us, if our question asks us to find f of x. So here's our question. So this is an example. Find the following. So if my first example is find f of 6, okay, what was this earlier? Okay, let's remember, let's go back over here, and I'm just going to put a little note. This was, if you remember, f of x, right? So whenever I put a number in there, I'm replacing the x value, or I'm replacing the independent value. Okay? So what this is really asking me is to say, hey, find the function that is produced, or find the dependent value that is produced when I input the 6. So when my independent variable, because remember, I replaced my x value, I replaced the independent variable with the 6, so it's telling me to find the y value, or the dependent value, when I use an independent value of 6. So when x is 6, what is y? Okay? When x is 6, what is y? Okay, so if I'm using this graph that I have right here on the right, and if you have the Cornell notes, that's the graph that's provided. It's an exact replica of that. If I'm using this graph, what I would do is I would go to my x value of 6 and find my x value of 6. So here's my x-axis. And I'm going to go over here. 1, 2, 3, 4, 5, 6. So this is 6 on my x-axis. Okay? I got to find out where I have a y. So what I would essentially do is just say, okay, here's my 6 value for x. Where is the point on that line there? Where's the point on that 6? If I come down here, I see there's a point right here. So what is the y value? Okay, the y value of this is 3. So the ordered pair for this point right there is 6 over, I'm sorry, I said 3, negative 3 down. So 6 over, negative 3 down. So if I know my x value is 6 because that was given to me in their problem, what is my y value? My y value when it's 6 is negative 3. Remember, we control independent, dependent is based on something. In this case, my dependent is based on the 6. So you could also restate this as when x equals 6, on this function here, y equals negative 3. Okay? Same thing. That means the same thing. Okay? Let's look at another example using the same graph. Let's say I want to find f of 0. Okay? What is f of 0? Again, look what's replaced here. I'm sorry, let me change that example, especially if you're using the Cornell notes, because that you can write this in your Cornell notes. Let's say I have f of x equals 0. Okay? In this case, is my x value replaced here? Is my x value have a number? No, it doesn't have a number, so that is what I'm looking for. I'm looking for the x value when my y value is 0. Now it's telling me, hey, x I don't know, because that's why it's still a variable, but my y value is 0. So let me go ahead and go to y0. So where's y0 at? Well, y is 0 right here. So here's where my y is 0 at the origin. Okay? So I'm not going up. So where do I have a point that's on the y-axis? Because if I don't go, on the x-axis, if I don't go up or down any, okay, essentially my y is 0. That means my point must be on the x-axis. So here, I have my y value of 0. So again, I'm making my dots just like I did before to help find that point. So where is a point that is associated with y being 0? If you see this dot right here, that's a point where y is 0. So what are the ordered pair here? What's the ordered pair of this point? This is 1, 2, 3, negative 3 over, so my x value is negative 3, and 0 up. So now, kind of opposite of this one, when y is 0, my x value, okay, x equals negative 3. So what this says is x equals negative 3 when y is equal to 0. So I just found a coordinate basically that has a y value of 0. Up here, because this x was filled in, I found a x coordinate of 6 on my graph, and I wanted to find the y value, so I did that. Okay. Again, if you have any questions, especially on those Cornell notes, go ahead and write those questions down. Come see me in tutoring in the morning, or ask me during class after your quiz. Okay? Okay. Last but not least, since we're still looking at this table, is this table a function? I keep calling table. Is this graph a function? Okay? Yes, the graph is a function because I don't have the ordered pairs of all of them. I have 2 ordered pairs that I figured out. Instead of for me finding all the ordered pairs and looking to see if any x values repeat, I'm going to do a vertical line test. So I'm going to do a vertical line test through this one. And I'm going to see that it only passes through one dot. Here's another dot or point. Only passes through one point. Okay? Here's another point. Only passes through one point. Here's another point. Only passes through that point. Only passes through that point. We already did that one. So since my vertical line test passes for all the points, this is a function. So yes, this is a function because it passes the vertical line test. Okay? If you wanted to find every coordinate and compare all the x's, you could do that and say yes, it's a function because no x repeats. Okay? But when it passes the vertical line test, I know that no x value repeats. Okay? All right, let's look at a different type of representation. So here's another one. Okay? Let's look at mapping. So if I have mapping, okay, I have, in this map, I have -2, 3, and 4. And these are my x values. Over here, I'm going to have my y values. And I'm going to have 3, 5, and 8. So I'm going to go ahead and connect my coordinates. Okay, -2 to 3. I have 3 to 3. I have 3 to 5. And I also have 4 to 8. Okay? Now, again, using our function notation, if it says find the following, and find f of x equals 8. What value are you given now? Are you given the x value or the y value? If you said the y value, you'd be absolutely correct. This is the y value, so I need to find y being equal to 8 and figure out what its x value is. When that x is unknown, I've got to figure that out. So here, my y value is 8. What x value is associated with that 8y value? Well, follow the line and you'll see 4. So if f of x equals 8, then x equals 4. So when x is 4, y is equal to 8. And again, you could write an ordered pair, 4, 8. So when x is 4 here, it's going to give you an 8. When I input 4, I'm going to output 8. Input for independent, output for dependent. Okay? So that's when x is 4, y is equal to 8. Okay? Any questions on that? If you have any questions, write it down so you can come see me in tutoring. Okay? All right. Let's look at another example. This was A, we'll call this one B. What if I have f of 3 equals what? Now, what am I replacing here? What value is being replaced now? That's right, the x value is being replaced now. So now I need to find the y value. So when I have an x of 3, so x equals 3, what is my y value? Okay? When x equals 3, I go over here to 3 on the x side. My y value equals 3. And if you notice here, here's 1, here's 2. My x equals 3 and my x equals 5. So f of 3 is 3 and 5. I actually have two answers for that one. That should raise a red flag to you. I have two y values for this x because this says when x is 3, I have a y of 3 and 5. That should raise a red flag to you. What does that tell you about this particular function or not function? That's right. I now know that this is not a function because the x value of 3 has two y values. when I used to teach functions a lot in previous years, one of the things I'd make my class do is repeat this over and over again was, for every x, there's only one y. For every x, there's only one y. We used to do that in class all the time, and every day we'd repeat that, just so that we knew that it was not a function if an x had more than one y. In this case, this x has two y's. Since it has a y value, two y values, that means that x has to repeat. So that's, again, why it is not a function. Okay? All right, pause the video if you need to, because I'm about to erase this. We can go to our next example. Okay, what if we're given coordinates or ordered pairs? What if I have a bunch of ordered pairs? So I have 5, 3, 2, 7, 7, -2, and 5, -3. So now I have a relation, a set of ordered pairs, and a different representation. Okay? Same things apply here. If I want to find f of -2, what is it replacing? What is it telling me I have? It's telling me I have an x value. It's absolutely right. X equals -2. So it's asking me to find the y value when x is -2. So I look for an x of -2. X is 5. Remember, these are x, y, x, y, x, y, x, y. Oh, this should be, and I wrote this wrong on the exam, this should be -2 right here. Okay? So I look for my x value of -2. I find my x value of -2 right here, and it has a y that is equal to 7. So when when x is -2, y is equal to 7. So my answer would be f of -2 equals 7. Okay? Input -2, and you're going to get a 7 for the output. Okay? Let's look at another example. Let's say we're given f of x equals -3. Again, okay, what am I given this time? This time I'm given the y value. It's telling me the y value is -3. So if the y value is -3, what is my x value? Okay, all I have to do again is go up to my ordered pairs and find my y value that's -3. Well, here's a y of 3, y of 7, y of -2. Here's my y of -3. What x value is associated with that one? That's right, it's 5. So when my y, this is what it's saying, when my y is -3, what is my input? What is my independent variable? What is my x value? When my y is -3, my x value is 5. So in this case, x would equal 5. And again, I could write these in ordered pairs. -2, 7, and 5, -3. Okay? All right, is this a relation? Why or not? Why not? I'm sorry, is this relation a function? Excuse me. Is this a function? Okay? Yes, it's a function because do any of my x values repeat? Oh, they do repeat. So no, it's not a function because my 5's repeat. So no, not a function because the x value of 5 repeats. So it's not a function because my x value of 5 repeats. Okay? Again, any questions, write it down, come see me in tutoring, or ask me in class tomorrow. Okay? Pause this if you need to get it down. I'm going to erase it for the next example. All right. Almost done. Couple more examples, and then we are done. Okay? Now, one of the great benefits of having function notation is that you can name your function. It's not always going to be f of x. Sometimes you might have g of x or h of x or something like that. And that will allow you to name your function so that you can work with multiple functions at one time without having to constantly repeat yourself. Okay? For example, let's say I'm given if I'm given h of x equals, sorry, let's change it up a little bit too. Let's see it a different way, because we're not always going to see x either. So let's have h of n equals negative 2n plus 4. Okay? If I have h of n equals negative 2n plus 4, this is telling me I'm using the h function, and my independent variable now is not x. Even though we would plot it and graph it on the x-axis, it's being represented by the n, so n is the independent now. It acts just like x, it's no different, and now h is the h of n is the y value, okay? So, if this is it, this would be called my h function, my h of n function, because I have an h and an n instead. So, if I'm given this function, and it says find h of 5, what that's telling me to do, basically, is to go to my h function and plug in 5 for the independent variable. So here's 5 for my independent variable. So all I have to do is say, okay, h of 5 equals negative 2 times, notice, this n was replaced by 5. So if this n was replaced by 5, I've got to replace this n by 5 plus 4. Now, once I replace this n with 5, or this x, or this independent variable of 5, I never touch that again. It stays there all the time. Okay, I don't have to move this around. That stays there. So then as I continue to solve this, I'm going to have h of 5 is equal to, and then I just simplify this side. So negative 2 times 5 is negative 10 plus 4. I just bring it down. So this becomes negative 10 right here, and bring the 4 down. I continue to simplify. H of 5 equals negative 6. Negative 10 plus 4 is negative 6, and then I am done. That is my answer. H of 5 equals negative 6. And you need to get in the habit of working this systematically and organized and finishing with your answers saying h of 5 equals negative 6, because that tells me specifically what my independent value I was looking for was and what function I was using. Because in a second we're going to get into two functions at one time. And you might be able to have two functions and solve several problems with those two functions. Okay? Let's look at another example, same one. What if I wanted h of 2? How would I do that? What was replaced here? I'm sorry, what if I had, excuse me. What if I said h of n, keep writing 2, excuse me. If I had h of n is equal to negative 2. Okay, again, what value is it telling me I have? It's telling me I have the y value, or the h of n value. So how would I plug that into this function? Okay, well, wherever there's an h of n, I can replace the h of n with a negative 2. So, if I take this h of n here, and I say, okay, I know that's negative 2, I can put that there. I know negative 2 equals negative 2 and plus 4. So just like the previous examples, I'm given the dependent variable. Now I'm solving for the n. I'm solving for the independent variable. So now I just need to solve this equation for n. So, try to get everything away from the n. So I'm going to subtract 4 from both sides. It's going to give me negative 6 equals negative 2n, because those cancel out. Now I'm multiplying negative 2 times n, so the opposite of multiply is to divide by negative 2. Those cancel out. Negative 6 divided by negative 2. Two negatives dividing each other equals positive 3. So my answer is n equals 3. So when my y value is negative 2, my x value is 3. So again, I can actually make coordinates out of these as well. Here, my coordinate would be 5, my x value would be 5, my y value would be negative 6. Here, I know my y value is negative 2 because that's what it told me from the very beginning. So my y value is negative 2, okay? Then what is my x value? Well, it's 3, that's what I just figured out. So that's the ordered pair that goes with those functions. I know this is a little more complicated. If you need to pause and rewind and watch it again, please do that. Make sure you understand this. Again, write any questions down that you may have and ask those questions in tutoring or after school, or in class, excuse me. Okay, pause it if you need to. We're going to look at one more example and then we're done. Okay, similar concept to the last one. Let's say we're given the functions f of x is equal to 3x minus 1 and g of x is equal to 5 minus x. So now in the problem I'm given an f function and a g function. Okay? So now if I'm asked to find anything particular, I would have to go to whatever function it's asking me. I'm not going to solve everything for both unless it tells me to. So if my first example says find f of 2, then I would go to the f function and plug in 2 for the x, just like I already did. I already plugged in 2 for x here, so I plug in 2 for x. Okay, so then I'd have f of 2 equals 3 times 2 minus 1. So f of 2 equals 3 times 2. Again, now I'm just simplifying. 3 times 2 is 6 minus 1. F of 2 is equal to 5. Whenever I'm given the independent value, it's significantly easier than if I'm given the dependent value because I don't have to solve an equation. All I have to really do is plug it in and simplify, which makes it easier. All right? Let's say I was given another example. Let's say I was given g of negative 1. Okay? I'd go to the g function and I would plug in negative 1 for the x value because the negative 1 was plugged in here. I plug it in here. And now I would just do 5 minus negative 1. This is part of the function, so make sure you don't just replace that negative with this negative. They both have to be there. Now, we always want to try to get rid of our double signage as quick as possible. 2 negatives will make a positive. So I'll get rid of this double signage and rewrite my equation, or my function, as g of negative 1 equals 5 plus 1. Now I just simplify. G of negative 1 is equal to 6. Okay? So now I've found a function for f and a function for g, and I knew where to go because it told me g of negative 1, go to the g function. F of 2, go to the f function. Now, every now and then they'll throw some other stuff in, like this. What happens if the problem says, and this is our very last example, what happens if the problem says f of 2 plus g of negative 1 equals. I would do exactly the same thing as I did in A and example B, but once I had the result, I know f of 2 equals what? Because I've already worked out the problem, f of 2 equals 5, and g of negative 1 equals what? 6. So then it's just asking me 5 plus 6 equals 11. So my answer would be 11. So f of 2 plus g of negative 1 equals 11. Okay? This is just saying, hey, the result of f of 2 plus the result of g of negative 1, what is the answer? What's the combination of those two functions? You can see multiplication, you can see division that way, you can even see a function in a function, which you'll see in Algebra 2 eventually. Okay? So, but one thing I do want to point out before I close up on this video is make sure that you see how it worked. I kept the f of 2 all the way down. That's the organized work that you need to strive for so that we know what you're doing. Now, hopefully you learned a lot from this video. This was a lot of information. Make sure you have it down. Put the notes in your notebook. Again, we talked about function notation. Function notation is a more easy-friendly way to write an equation or a function. And again, y is replaced by f of something or g of something or p of something or whatever. Okay? So make sure you understand function notation. Again, this makes life easier for you. So I will see you guys tomorrow. Be prepared, studying and preparing for your quiz. Good luck.